Hello, let's discuss Physics 9702 Variant 12. It's May-June 2019. So question number 1 is that what is the equivalent to 2000 microvolts? 2000 microvolts is 2 into 1000 into micro is 10 into 10 to the power negative 6. So it's 2 into 10 to the power negative 3, which is 2 millivolts. So B seems to be the appropriate answer. So it's B, 1B. Question number 2 says that what is the number of SI base units required to express electric field strength and power? In this question, what you have to do that you have to formulate electric field strength and power into pieces. Like electric field strength is voltage applied per unit distance, and voltage is energy supplied per unit charge or work done per unit charge. So further you have to do is work done as energy supplied per unit charge over distance, and further you have to do is work done as FD over Q divided by D. So what you can do is divide F into MA, so A into D over T square. So what you can do is see that M, D, T and Q are the 4 basic charges, SI base units. So for power you can do the same. Work done per unit charge, work done is FD, F is MA, so and A is D by T square. So what you can see is that M, D and T are the 3 units for power. So that's question number 2. The answer is D. Question number 3 says that the Planck constant H has SI units Js. Which equation could be used to calculate the Planck constant? For A, you can see that it's H equals dE over V, where D is the distance, E is the energy, and V is the velocity. So D is the distance, which is meter, E is the energy, which is joules, and divided by meters per second. So it's meters and the seconds comes upwards, so meters cancels out with meters, so it becomes joules second. So A seems to be the appropriate answer because it's joules second. For question number 4, it says that 2 cables are attached to a bracket and exert forces as shown. What are the magnitudes of the horizontal and the vertical components of the 2 forces? So what we can do over here is that we can just divide this 15 Newton into the horizontal component and a vertical component, the 6 Newton into a horizontal component and a vertical component, just like this I have shown over here. So just add them up. The horizontal components become 15 cos 20, 15 cos 20 and 6 sine 40. So this becomes 18, and the vertical components become 15 sine 20 plus minus 6 cos 40. So this becomes 0.534. See, 6 cos 40, it's in this direction, and for the 15 one it's in upward direction, so they are in opposite direction, so it gets minus, so 0.524. So it's C. Question number 5, that's a repeated question. It was asked in November 2013. So it says that a student wishes to determine the density P of lead. She measures the mass and diameter of a small sphere of lead. The mass is given, the diameter is given. What is the best estimate of the percentage uncertainty in her calculated value of P? So what we can do is we can just find a density. Density is, you know, the mass over volume. Volume is 4 by 3 pi r cube. You can convert the radius into dia and it becomes pi d cube divided by 6. Density becomes 6m by pi d cube. So change in P over P equals change in m over m, because you can see that m is single, and plus 3 change in d by d. It's 3 because it was d cube. So when you are finding the uncertainty, the power comes in front of the uncertainty. So it is 0.037, and we have to find the percentage uncertainty. So into 100 it becomes 3.7. So the answer is D. Question number 6, it says that 2 quantities P and Q are directly proportional to each other. Experimental results are taken and plotted in a graph of Q against P. Which graph shows there were random errors in the measurements of P and Q. So one thing you have to know is that P and Q are directly proportional to each other. So this must be a straight line and it must pass through the origin. So it's either A or C. And now it says that which graph shows that there were random errors. No, you have to know that for random errors can be less or more than the true value. So this straight line is the true value. The measurements could be less or more. Over here the measurements are just more or equal. So it's C, the appropriate answer. Question number 7, it says that a man of weight 75.2 kg uses a set of weighing scales to measure his mass 3 times. He obtained the following readings. Reading 1 is 80.2, reading 2 is 80.1, reading 3 is 80.2. Which statement best describes the precision and accuracy of the weighing scales? Now the first thing you must observe is that the true value is 75.2. And the readings over here are 80.2, 80.1 and 80.2. So the values are not accurate. Okay, they are precise. You can say that it's not precise. No, it's precise because it's precise up to 0.1 kg. Precise to 0.1 kg and not accurate to 0.1 kg. Are they accurate to 1.1 kg? No. So the answer is D. Question number 8 says that the graph shows how a physical quantity varies with time. Which event could best be represented by the graph? The acceleration of a firework rising to a maximum height and falling to the ground. No, there are just 2 events. Over here there are 4 events happening. In B it says the acceleration of a skydiver leaving an aircraft, falling, opening a parachute and falling to the ground. Yes, maybe. Let's see. If it leaving an aircraft, acceleration is decreasing. Yes, it's decreasing. Falling, and then it becomes at constant velocity. The parachute opens, terminal velocity, it achieves terminal velocity, so it's x. Parachute opens, constant velocity, and then he falls and then tries to decelerate himself. Yes, after falling it decelerates. It's y, it's the y region, and then he halts, he stops. Acceleration becomes 0. So it's Z. You can say Z as halting, or you can also say that when he becomes, or when he is decelerating, the speed becomes constant. You can also say this way. Okay, so it's B. In C also, the graph of the speed of a javelin as it leaves an athlete's hand. This is also not the relevant event, and D is also not the relevant event because this graph is just like this as drawn. Question number 9 says that what describes the mass of an object? The force the object experiences due to gravity? No, that's not the mass. The momentum of the object before a collision? No. The resistance of the object to changes in motion? Yes, that's what we have studied in O levels also. So it's 9 is C. Question number 10. It says that a car has mass m. The person needs to push the car with force F in order to give the car acceleration A. The person needs to push the car with force 2F in order to give the car acceleration 3A. What expressions give the constant resistive force opposing the motion of the car? That's quite simple. Resultant force is applied force minus resistive force. Ma equals F minus R. So for the first, it says that a car has mass m. To push the car with force F in order to move the car with acceleration A. So it's basically R resistive force equals F minus Ma. So resistive force equals F minus Ma. Just rearranging this formula. So it's simple. That's the first equation. The second equation says that the person needs to push the car with force 2F to move the car with acceleration 3A. So resistive force becomes 2F minus 3Ma. So the acceleration is 3Ma. So 3Ma. So there are the two equations. R is the same. Just equate F minus Ma equals 2F minus 3Ma. And you will get F equals 2Ma Therefore, R equals 2ma minus ma, which equals ma. So R equals ma. So A seems to be the appropriate option. Question number 11 says that two bar magnets P and Q are mounted on floats which can slide without friction along an air track. The two magnets slide towards each other along the air track and interact without making contact. The relative speed of approach of the magnet is equal to the relative speed of separation. So with this thing you must know that the relative speed of approach is equals to the relative speed of separation. You should know that there is conservation of kinetic energy. So this question becomes straightforward, that A said that during interaction between P and Q some of the total kinetic energy is lost. No. During the interaction between P and Q some of the total momentum is lost. No, it's always conserved. The momentum of Q after the interaction is equal to the momentum of P before the interaction. No. D, the values of kinetic energies before and after the interaction are equal. Yes, exactly, that's what it says. So 11, it's D. For question number 12, it says that a submarine descends vertically at constant velocity. The three forces acting on a submarine are viscous, drag, upthrust and weight. Which relationship between their magnitude is correct? Since the submarine is descending at constant velocity, so constant velocity means that the upward forces are equal to the downward forces. What's the downward force? Weight. What are the upward forces? Upthrust and drag. So weight equals upthrust plus drag, so weight must be equal than the upthrust. That's a possible good answer, so it's D. Question number 13 says a small positive charge can move inside a uniform electric field. The charge moves along different straight paths between point P, Q, R and S. Each row gives two paths that results in the same total work done on the charge. So work done is F into D, where D is the distance or the displacement. So path 1 and path 2. Now it says P to R, path 1, P to R and Q to S, P to R and Q to S. No, P to R is along the electric field and it's against the electric field. So it can't be the same. Path 1 is P to R and path 2 is P to S. No, they can never be same, because P to S is no work done. It's just same thing because the displacement is 0 along the electric field. C is S to Q and S to R. Yes, the total work done is same, because S to R work done is also the work done S to Q, because in moving from S to Q, the distance is the distance SR. You should know this because it's to cause theta. So let's see. Question number 14 says that a car of mass m travels at constant speed up a slope at an angle theta to the horizontal as shown in the diagram. Air resistance and friction provides a resistive force F. The acceleration of the free fall is G. What is the force needed to propel the car at this constant speed? So you should know that the car is moving at constant speed. So the upward force along the slope equals the downward force along the slope. So this is the one force along the slope, which is F. The second force is due to the weight, which is mg sine theta. This angle is theta. You know that this angle and this angle is same. So mg sine theta plus F is the force needed to move the car with constant speed. So it's D, mg sine theta plus F. It cannot be cos theta, because cos theta will be this component, the downward component. That's not possible. Mg sine theta, mg cos theta, it cannot be the value, so it's D, 14D. Question number 15 says a volume of 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is 1000 kg per meter cube and the density of alcohol is 800 kilogram per meter cube. The volume of the mixture is 2 meter cube. What is the density of the mixture? So for this question, let's see. Excuse me. That the volume of water is 1.5 meter cube. The volume of alcohol is 0.5 meter cube. The density of water is 1000. The density of alcohol is 800. So, and the volume of the mixture is 2 meter cube. So you can calculate the mass, density into volume. It's 1500 kg mass of water, and mass of alcohol is 800 into 0.5. That becomes 400 kg. So you can calculate the total mass of alcohol plus water. It's 1900 kg. And then you can find the density of the mixture. Density of the mixture will become the total mass divided by the total volume. The total mass is 1900, the total volume is 2, so it's 950 kg per meter cube. So the appropriate answer is D. Question number 16 says that a parachutist is falling at constant terminal velocity. Okay. Which statement is not correct? It says that gravitational potential energy is converted into kinetic energy of the air. Gravitational potential energy is converted into kinetic energy of the parachutist. Gravitational potential energy is converted into the thermal energy of the air. Gravitational potential energy is converted into the thermal energy of the parachutist. So you have to underline this statement: constant terminal velocity. So this means that the velocity is constant and there is no gain in velocity. Okay, it's constant, it remains the same. So it says that gravitational potential energy is converted into kinetic energy of the parachutist. No, there is no increase in energy. Okay, the velocity is same, it's constant velocity. If the velocity is constant, half mv square is constant, half mv square is constant. There is no increase in energy or kinetic energy. Okay, so it's B. The rest can be possible because it's thermal energy or whatever it says, it is possible. The thermal energies are always possible in the air or of the parachute. Question number 17 says that a combined heat and power station generates electrical power and useful heat. The diagram shows the input and output power for a CHP steam. Input power: what is the efficiency of the CHP station for producing the useful power? So you have to identify what are the useful powers. Useful powers are 100 megawatt and 160 megawatt. 60 megawatt is the wasted power. So the total power is 100 plus 160 plus 60, and the input power is 160 plus 100. So 100 plus 160 divided by the total power into 100. That's the efficiency, which is 81. So the answer is D. Question number 19 says a bungee jumper jumps off a high bridge. When attached to it by a long elastic rope which obeys Hooke's law, the gravitational potential energy of the jumper is measured relative to the lowest point reached by the jumper. Which graph shows the variation of the gravitational potential energy of the jumper and the elastic potential energy in the rope with the vertical distance fallen from the top of the bridge? So he is falling from a height downwards, so that means that potential energy is being decreased and kinetic energy is being gained. Okay, so one thing you should know is that for a gravitational potential energy, it must decrease, and it must decrease uniformly, because gravitational potential energy is mgh. Gravitational potential energy is mgh, so it's directly proportional to h, but it's decreasing over here. Sorry. So either it's A or it's C. Now let's come to the elastic potential energy. For elastic potential energy, you must know that elastic potential energy, the formula is half into force into extension, and force equals KE. So this becomes half K extension square. Half K extension square. So the X is the extension. So E is directly proportional to X square. So E is equal to X is directly proportional to x square. How is the graph of x square? Just like this. It's a. It's not this. It's x square. It's increasing. Okay, so 18a. You just have to revise the formulations. You should know the formulations for these type of questions. Question number 19 says that a train on a mountain railway is carrying 200 people of average mass 70 kg up a slope at an angle of 30 degrees to the horizontal and at a speed of 6 meters per second. The train itself has a mass of 80,000 kg. The percentage of the power from the engine which is used to raise the passenger and the train is 40%. What is the power of the engine? So the questions like this, you have to just calculate the total mass. What's the total mass? The mass of the passengers and the mass of the train. The mass of the passenger is, there are 200 passengers, each of mass 70 kg. 200 into 70 plus 80,000 kg is the weight, is the mass of the train. So it's 94 kg. So next, what you have to do is that you have to F equals mg. You have to find the force, and the force, it's on a slope. Because the train is on a slope just like this, so there is some angle theta, so the force acting vertically along the slope, the total mass is, for example, the mass, it's along the slope, it's sine theta. Remember in the previous question we said that in a question on a slope, we just did what to say about it. Yeah, we're here. This, consider this a train, it's moving up a slope, so we have to consider this thing, mg sine theta along the slope. Okay, so it's mg sine of 30, so it's 461,070 Newton, the force. Okay, so the output power is P is equals to force into velocity. Velocity is given. Velocity is 6 meters per second, so it becomes 2.76 into 10 raised power 6 watt. So the efficiency is given, it's 40%. So we have to find the power of the engine, the input power. So it's 0.4 equals P out over P in equals 2.76 into 10 raised power 6 divided by P in. So P in, the input power, is 6.9 megawatt. Just calculate it like this. You just have to know, for this question, you just have to know that it's along the slope and the formulas, and that's it. Question number 20 says that a wire X is stretched by a force and gained elastic potential energy E. The same force is applied to wire Y of the same material with the same initial length but twice the diameter of wire X. Both wires obey Hooke's law. What is the gain elastic potential energy of wire Y? So that's a good question. You just have, that's a bit mathematical question. So what you have to know is that initial extension is E1. Let's call it E1, and the elastic potential energy initial is E1. E1 equals half force into extension. So force could be written as stress into area, half into stress into area. Okay, so now from here what you can do is that you can evaluate this thing. Area is inversely proportional to extension, so you can calculate the extension 2 for when the diameter is doubled. When the diameter is doubled, the radius also doubles, so I have doubled the radius, no problem. So just calculate the E2. E2 becomes E1 over 4. Okay, so so E2 becomes half into force into E2 extension 2, and you know that half into F into E2 is E1 by 4, so E1 by 4, half into F into E1 is E1 extension, elastic potential energy 1, so E1 divided by 4 becomes 0.25 E1, so E2 elastic potential energy becomes 0.25 E1. So that's simple mathematics. 20, we got it. A. Question number 21, it says the diagram shows the arrangement of an atom in a particular crystal. Each atom is at the corner of the cube. The mass of each atom is 3.5 into 10 raised per negative 25 kg. The density of the crystal is 9.2 into 10 raised per 3 kg per meter cube. What is the shortest distance between the center of the two adjacent atoms? Now, what you have to do is that you have to find the distance between the two adjacent atoms. So you have to find the length of a cube. So consider this whole thing as a cube. What you can do is you can find the volume of the cube, and from the volume of the cube you can find the length of the cube. So density is mass over volume. So volume, you are given with the mass and volume. Calculate the volume and take the cube root of the volume. So it will give you the length, which is 3.4 into 10 raised per negative 10. You just have to use your common sense for it. Question number 22, it says the stress strain graph for loading and unloading for 4 different materials as shown. Which graph exhibits purely elastic behavior? For elastic behavior, the material should come back to its original position, which is only B. The D, C and A are not. That's all. That's an easy question. 22B. The diagram shows the position of a particle in a progressive wave at one instant in time. The speed of the wave is v, p and q are 2 points in the wave a distance L apart. What is the expression for the frequency of the wave? Consider this thing as a compression and consider this thing as a rarefaction. So it's half a wavelength. We know that it's half a wavelength. It's not a complete wave, it's half wavelength. It's compression to rarefaction is half wavelength. You all know that. So L, the length L becomes lambda by 2 and lambda becomes 2L. So frequency is V is equals to F lambda and F equals to V over lambda, and lambda is 2L. So F equals V over 2L. So A is the answer. Question number 24. That's an interesting question. The wave questions are always interesting. A wave moves along the surface of water. The diagram shows the position of the displacement S with distance along the wave at time t is equals to 0. This is a wave and there is a point P, distance along with the direction of the shell. Which graph shows the variation with time t of the displacement point on the wave? So for this question, you should consider 2 things. First, that point P has this much displacement. So this much displacement must be there. Either it's in A or it's in C or it's in D. And the second thing is to find the next instant. What should be the next instant of P, particle P? So for it, you just have to make a next instant graph, a right shifted sine graph, similar to this, a right shifted a bit. You will come to know that P goes up. You will come to know that P goes up, just like this. P goes up. If you move it over here, then you will notice that the point P goes up. So either A, it's going down, C, it's going down, D, it's going up. So it's D. You get that? 2 things to consider, and I have told you that. Question number 25 says that in an experiment to determine the wavelength of sound in air, a stationary wave is set up in an air column. The distance between a node and an adjacent antinode is L. What is the wavelength of the sound? That's quite simple. Node and antinode, the distance is lambda by 4. Node and node, the distance is lambda by 2. Node and antinode, the distance is lambda by 4. So lambda L equals lambda by 4. Lambda is 4L. Just make lambda the subject. It's D. Question number 26, it says, in one of the first experiments to demonstrate the Doppler effect, a train was filled with trumpeters, all playing a note of frequency 440 Hz. The difference in observed frequency of the note as the train directly approached a stationary observer was 22 Hz. The speed of the wave was 340 meters per second. At which speed was the train moving? So he is basically asking for source velocity. We are given with the source frequency. We are given with the observer velocity. We are given with the difference in frequency, so we can add them up. We know it's approaching, so the frequencies would add up. So observer frequency become 462. 440 plus 22, it's 462 Hertz. Just plug in the values and find Vs. So Vs is 16.2. This formula is also given in the formula sheet in the start of the paper. Question number 27 says the electromagnetic spectrum consists of waves with different wavelengths. Which row correctly identifies the region of the electromagnetic spectrum? That's a recall question. You just can memorize it in this way, that Rm equals G, increasing frequency. That's an increasing frequency, gamma being the highest frequency. So gamma have the highest frequency and the least wavelength. So you can see that the least wavelength is starting from here: X-ray, ultraviolet, infrared, microwave. Question number 28. As a cathode ray oscilloscope is used to display the trace from a sound wave, the time base is set at 5 microseconds per millimeter. What is the frequency of the sound wave? You just have the time base setting is given. You just calculate the boxes for one complete wave. It's 1, 2, 3. 3 blocks. Okay, so 3 blocks means 3 centimeters. Okay, and the time base setting is 5 microseconds per millimeter. Convert this millimeter into centimeter. So this becomes 5 into 10 to the power negative 5 seconds per centimeter. So the time period is 3 into 5 into 10 to the power negative 5. So this becomes the time period. Just multiply them. You will get the time period, and take the reciprocal of the time period. You will get the frequency, which is 6.7 kilohertz. Thank you. If you like my video, kindly like my video and subscribe my channel. Thanks a lot.